Hello there, this is Sandeep Arora here. Welcome to my channel. My mission is to teach you AI so you can benefit from it in your work and in your life. Today I want to talk to you about how to build successful AI agents. Okay, so we are entering into an era from clicks and apps to agents and conversational UI. So today I want to talk to you about the discipline, the framework, and the mindset needed to build successful AI agents. Let's take a closer look. So AI agents are software systems which use large language models to complete a task or to achieve a goal. Okay, so they basically could involve multiple steps, and every step could use a different large language model. They could use tools to get data from within the enterprise, outside the enterprise. They could use functions, and the AI agent, based on the request, will orchestrate, reason, plan everything needed to complete the goal. Okay, so now this is very different than the deterministic systems, the traditional programming we are used to. So what happens is many teams use the methods they are familiar with, apply them on AI agents, and they fail. So let's take a closer look on the life cycle. So I'm going to talk about the different phases of an AI agent development life cycle, and I'm going to call out the goal of each step, and I'm also going to call out how each step is different than traditional programming. So in the design step, right, you define the goals of the whole agent. You also define the goals and the success criteria of every step. You also put in guardrails and the constraint that the agent and the steps can do or cannot do. Okay, so this is done in the system prompt and in different ways. You decide what tools you're going to provide to the agent. Okay, it could be API callouts, it could be web search, it could be data analysis. You decide the autonomy level, meaning does the agent do the task on its own? Is it a simple agent, or is it steered by humans like a replit? Okay, where a human is working with the AI agent. Hey, get me this. Example could be in a financial company where you have an AI agent which could search through 100,000 documents. So this agent works with a financial analyst to get it information. And then you build the prompts, you decide the steps, and you also decide what large language model for each step. So based on the step, the nature of the step, the large language model could be different. Okay, so there's going to be an overall LLM which does the reasoning and the planning, and then there are going to be various steps, and each step might call a different small language model, task specific model. Okay, and so you have to design all this, right? And this is very complex because this is not like traditional software programming. It's very loose, right? And AI generates data. Okay, it generates data. So the old rules of traditional development, testing, QA don't apply. Evaluation. Okay, this is critical, and I've put it on red over here. Okay, and you can download this deck. Okay, I've put a lot of time in creating this deck. Okay, now this is very different than traditional software testing where input output exception. Here it's not that case. Okay, here it's not that case. So this is the most important step. Your team needs to spend a lot of time understanding how to do it. Okay, because this is the foundation of successful AI agent building. Now what you're going to have to do is the teams have to learn how to test probabilistic AI systems as opposed to deterministic software systems. For that, for the agent and for every step, you're gonna have to create a golden data set. Okay, what is the expected input, what is the expected output? This can be very time consuming based on your agent, but you have to do that. Okay, you have to make sure the agent overall is doing the right thing, the planning and the reasoning is right, and individual steps are accurate, the right inputs are passed, and they are called in the right order, and then they are aggregated to produce the outcome. So just think about it. This is a lot of work. It is complex. So I advise teams to start with simple AI agents, 1 step, 2 step, 3 step, learn and then mature to create even more complex agents. So I mentioned about checking for tool correctness, plan correctness, quality, and then you have to decide on what evaluation metrics are suitable for your agent and for the tasks, right? So some learning has to be done over here. There are different principles. I can't cover them, but there is some learning to be done over here. And then humans are involved in this step. Okay. Now, once you have the evals and you have the design, you can start to build and test in an iterative manner, and based on the metrics, you can say, okay, this is good enough. Maybe 95% is good enough. It is it is a research agent, so that's fine. It's not making mission critical decisions. So you decide. Then observability. This is critical, right? This is critical because once you put an AI agent in production, you're gonna need humans to manage it, to observe it. And the way you have to think about it is humans managing a digital workforce. You must have heard Jensen Huang and Mark Benioff talk about digital workforces. So you have to think in terms of create a small team to manage and observe your digital workforce. What does that mean? In production, you are going to observe and spot check whether the AI agent is working fine or not. If your users create an incident or they report errors, you're going to have to take it and backtrace it and say, what happened? Did it fail in a step? Did it fail in the order of steps? Or did it fail in the plan? You don't know. So that is where observability comes in. The small team, always active, observing and managing your digital workforce, which is your AI agents. With this kind of thinking, you will develop the AI mindset to go from simple AI agents to even more complex and mission critical and reliable AI agents. Okay. So once you have a team, you have a process and a method to observe, the other step is you need to basically create alerts to make sure when something is going wrong, right? The AI system automatically alerts you. Okay, so this is humans are involved only when alerts are created. This is more of operations related, right? Real-time alerts if there is a LLM failure, or there is a tool failure, or there is a function failure, or maybe the costs are rising. Okay, so whatever, based on your use case, based on the metrics you care about, create alerts so that you are on top of it. You are proactively you are proactively informed if there are any errors, any violations, any drifts, or any latency issues. Oops. Okay. Analytics, this is critical. And you most likely you're gonna use tools from a SaaS company, or you're gonna use frameworks. And this is important because analytics is important because you can see what trends are emerging. Okay, so what are the most use cases, what are the most type of errors, and this helps to again continuously optimize your AI agent. What is the user behavior? Maybe you have designed an agent, and users use only a part of it, right? So user behavior, agent behavior, your analytics will help you tell, okay, for this data it is corrupting, efficiency, business insights. So this analytics, you have to set up visual dashboards so that you can see the health of an agent, you can see health of your digital workforce, and you can see what business trends are emerging so that you can profit from it. And then the last is audit. Okay, what is audit? So if you're going to deploy AI agents into production and you are in a regulated industry, okay, and you make decisions, your AI agent makes decisions, 2 years down the road, somebody might come back and say, hey, why was I unfairly treated, maybe 2 months later, right? Or maybe I deserved this outcome, I deserve this refund, why was I not approved? So you got to have the protocols and the digital footprint in place so that you can backtrace the step of the AI agent, what planning it did, in what order it called the tools, what was the input, what was the output of every step, every tool, every function, and how it arrived at the decision. So that if the regulators of this, or there is litigation, you have a digital footprint of the plan of the entire agent, stack trace. So this is high level and hope this is helping. And again, the key is continuous optimization, because you will not get it right the first time. It is gonna be a process of continuous optimization. Okay, so after every evaluation you optimize, after observing spot checking issues you optimize. It's a continuous cycle of optimization, and it's a ever going process. So I think that's it. Hope you enjoyed. You can download this deck from I'm going to provide a link in the YouTube. I'm going to see you soon again. Thank you. Bye bye.